Final thing that I want to look at is what happens if you have complex roots. So let's look at something like x squared y double prime plus xy prime plus 4y equals 0. And same story, y is x to the m, y prime is m x to the m minus 1, y double prime is m times m minus 1 x to the m minus 2. Plug everything back in and you're going to end up with I'm going to skip some details here, but you can do it if you like. You're going to end up with m times m minus 1 plus x times y prime is m times x to the m plus 4y is plus 1. So you're going to end up with this equation, which is going to give you m squared plus 1 equals 0. And therefore, your roots are going to be m is plus or minus I. Okay, and so let's think about what's going to happen if m is plus or minus I. Well, you're going to have your solution is going to be x to the, what did I do here? Did I screw something up? Oh, this should be a 4, not a 1, which makes this a 2i. Yeah, you're going to have x is 2i plus x to the negative 2i, where I is the complex number, so that when you square it, you get negative 1. But we need to be a little bit careful about what's x to the 2i or x to the negative 2i. And in general, I think it's worth just writing, if you were to have x to the, say, a constant times I, let's say ki, the right way to think about this is that this is e to the natural log of x to the ki, but then you can bring the ki down, and this is e to the I k natural log of x, and then we know what that is. That's cosine of k natural log of x plus I sine of k natural log of x. So for us, if we have m is plus or minus 2i, then our solution is going to end up being, we're going to have c1. And by the way, if it was a negative here, it's the same trick as before. When you have the positive 2i and the negative 2i, those complex solutions always come in pairs. It turns out that you can use the evenness of cosine and the oddness of sine, group them all together, and it turns out that you're going to end up with y is c1 times, c1 times cosine of, what was our k here? Cosine of 2 natural log of x plus sine of 2 natural log of x, but you can just group them together and you end up with c2 sine of 2 natural log of x. Okay, because you could have c1 cosine 2 natural log of x plus c2 sine 2 natural log of x plus the ones with the minus 2 in there, but the minus you could just group together, and the minus here you could group together and rename your constant in front. So it turns out that this is the right way to think about the general solution when you have complex solutions.